In this video, we're going to look at solution stoichiometry. As always, the key is the mole-to-mole ratio. Given whatever you're starting with, you need to convert to moles to use that mole-to-mole ratio and then convert to the desired outcome. The first question reads, how many grams of silver chromate will precipitate when 150 milliliters of 0.5 molar silver nitrate are added to 100 milliliters of 0.4 molar potassium chromate? We need to come up with the equation first. So this will be silver nitrate reacting with potassium chromate. This is an example of a double replacement reaction, which will form potassium nitrate and silver chromate. At this point, we want to balance our equation. We can do that by putting a 2 in front of the silver nitrate and putting a 2 in front of the potassium nitrate. Looking at the information given in the problem, we're given 150 milliliters of silver nitrate, and we know that it's a 0.5 molar solution that we have 150 milliliters of. Our goal in this problem will be to convert to moles using the molarity equation, then do a mole-to-mole ratio, solving for moles of silver chromate that will form, and then convert to grams. There we'll use the molar mass of silver chromate, which is 331.73 grams per mole. Setting this math up, for our first calculation, we have molarity equals moles over liters. In this case, we're trying to solve for moles, so we want to get moles by itself. Plugging in our values, we have 0.5 molar and 0.150 liters. This gives us 0.075 moles of silver nitrate. The mole-to-mole ratio is 1 mole of silver nitrate per 2 moles of 1 mole of silver chromate per 2 moles of silver nitrate, otherwise a 1:2 mole-to-mole ratio. 1 mole silver chromate per 2 moles of silver nitrate. This means that when this amount of silver nitrate reacts with excess potassium chromate, it will generate 0.0375 moles of silver chromate. If we take those 0.0375 moles of silver chromate and multiply by the molar mass, we get 12.4 grams of silver chromate that form. In the second problem, we're asked how many milliliters of 0.280 molar barium nitrate are required to precipitate as barium sulfate all the sulfate ions from 25 milliliters of 0.350 molar aluminum sulfate. There's a lot going on here, but I think if we start with an equation, it'll begin to make sense. The problem tells us that we're starting with aluminum sulfate reacting with barium nitrate. Again, we're given a double replacement reaction that will yield aluminum nitrate and barium sulfate. We're additionally told this barium sulfate will precipitate as a solid, and we know that all nitrates are soluble, so we know the aluminum nitrate product is aqueous. At this point, we want to balance our equation. We can do this by putting a 3 in front of the barium sulfate, a 2 in front of the aluminum nitrate, and a 3 in front of the barium nitrate. Looking at our problem, we're asked how many milliliters of 0.280 molar barium nitrate are required. So we can plug in that information. And we also know that we have 25 milliliters of a 0.350 molar aluminum sulfate solution. So our general plan for this problem will be to convert the aluminum sulfate into moles, or rather to solve for the moles of aluminum sulfate contained in that amount of solution, do a mole-to-mole ratio, and then, given moles and molarity of barium nitrate, we could solve for the missing bit, the volume of barium nitrate required. Just like before, there's 3 steps to this problem. So we'll start by first doing a molarity equation. Here again, we know molarity equals moles over liters. We're looking to solve for moles, so we'll get moles by itself. 0.350 molar times 0.025 liters. And that gives us 0.00875 moles of aluminum sulfate. Our mole to mole ratio is 3 to 1, meaning we'll need 3 times as many moles of barium nitrate as moles of aluminum sulfate. That works out to 0.02625 moles of barium nitrate. Now we know our moles of barium nitrate and the molarity of the solution. We could do another molarity equation to solve for the volume. In this case, to solve for volume, you would get moles over molarity. Liters would be 0.02625 moles over 0.280 molar. That's going to work out to 0.09375 liters, which is equal, with sig figs, to 93.8 milliliters. As a review, in both cases, you start with what you're given, convert to moles, do a mole to mole ratio, convert to the final product. Start with what you're given, convert to moles, do a mole to mole ratio, solve for the final product.